draw the shear and moment diagrams for the beam shown in the figure. So in here, I am going to show how to draw the shear and moment diagram using the shear and moment function and then using the area method. So first thing that we are going to do is to compute for the reaction of the supports. So we have here for point A, we have two reactions, of course, the AY and the AX, but in this case, AX is equal to 0. Then at point B here, you have the BY. Now, for this loading condition, we have the resultant of the load can be found at 1/3, 2/3. So it's 1/3 of 9 from point B, so that's 3, and 2/3 of 9 from point A, and that's 6. So this is the location of the centroid where the resultant of the load is acting. So what is the magnitude of the resultant of the load? So it is the area of the load diagram. So we have here 1/2, the length is 9, and the height is 20. So we have here 90 kilonewton. Now if we are going to solve for the value of AY, what we are going to do is to summate moment at point B, taking the clockwise direction as positive. Therefore, we would have here AY, which would rotate clockwise, is positive, multiplied by the distance 9, minus the load 90, which would rotate counterclockwise, so therefore it is negative, and the moment arm of 3 is equal to 0. So therefore, computing for the value of AY, that would give us 30 kilonewton. And since we have the positive answer, meaning the assumption which AY is upward is correct. Now, if we are going to summate the forces vertical is equal to 0, taking the upward direction as positive, then we would have here the AY minus 90 plus BY is equal to 0. So, since AY is equal to 30 minus 90 plus BY is equal to 0, therefore, we have here BY is equal to 60 kilonewton upward, since positive yung lumabas na sagot. Since we already had computed for the value of the reactions of the support, so what we are going to do here is to draw our shear and moment diagram using the area method. Okay, so our shear at point A is just equal to the reaction, which is equal to 30 kilonewton. So meaning this is 30 kilonewton. And the shear at point B is just equal to 30 minus area between A and B. Since the area between A and B is just equal to 90 kilonewton here, which is the area of the triangle. So we have here 30 minus 90. That would give us negative 60 kilonewton. So in here, we have negative 60 kilonewton. Since this equation here is in degree 1, we are expecting na yung ating shear diagram is a degree 2 curve or a parabola. Since our load diagram here is increasing, so going back with the idea of DYIX, since increasing yung ating load diagram, therefore we are going to bend the x-axis. So yung point sa left, always yung origin natin, ibig sabihin yung next point natin, itong negative 60 is in the quadrant 4. So, ang x-axis natin is this. And ito naman yung ating y-axis. Since x-axis yung i-bend natin, so therefore, this would be our curvature. So, yung curvature natin dito, we have here a parabola. Yan. At kung titingnan natin, no, babalikan natin yung load diagram natin. Itong shear na to ay nabuo from the area of the load diagram from point A up to that point, no? So, itong area na to, ito yung nag-contribute para doon sa para mabuo itong shear dito. Ngayon, kung mapapansin natin, itong part na to, may dalawang area tayo. So, we have here the triangle and the area of the rectangle, no? Itong rectangle, degree 0 will create a degree 1, no? So, ibig sabihin, so dito sa shear diagram, siya ay makakabuo ng degree 1 na curve, no? So, dalawa to. Ito ay degree 2 at ito ay degree 1. And yung area nito, no? So, pangalanan natin siyang ito ay pangalanan kong area 1. And this is our area 2. Yung area 1 ay mag-create ng magnitude na to, no? So, kung ano yung area doon sa area 1, ito yung height, no, ng triangle. And this area to here would be the height of the spandrel, degree 2, no? So, later ay i-expand natin. I-elaborate ko kung ano ang ibig sabihin ng spandrel. Okay. So, out of this, magkakaroon ulit tayo dito ng dalawang area, no? So, itong area ng triangle and of course, itong area ng spandrel. Okay? So, ang goal muna natin dito is pasarahin, syempre, yung ating shear diagram. So, yung shear diagram natin at point B, kung makikita natin, ay negative 60 pa siya, no? So, this negative 60 here ay magiging 0 na siya kasi i-close siya nung 60 kN upward By. So, magsisiro na siya dyan. Ngayon, aalamin natin itong value ng x. Ito, yung x na to. So, para makuha natin yung value ng x na yan, since degree 2 na tayo dito, ay hindi na tayo makakagamit ng normal na ratio and proportion. So, kung papansinin natin dito, magkakaroon tayo dito ng, since we have here a parabola, no? So, kulayan ko ha. Itong green na to, ito yung parabola natin na nakikita natin dito, which has the length of x and the height of 30. Itong malaking parabola, ito yung hanggang doon, no? Sa point na to. Ito yung point na to ay ito yon. So, ito yung malaking parabola. So we are expecting our maximum moment here located at the location of the zero shear. So, pangalanan natin tong area 3 kasi meron na tayong area 1 and 2 sa figure natin. So, this is area 3 and ito ay area 4. Itong spandrel ay area 5. Okay? So, kumpitin natin yung area 3 kasi yan yung gagamitin natin sa moment. So, yung moment natin at 0. So, yung moment natin at A is equal to 0. For the area of the spandrel is equal to 1 over n plus 1 base times height. So if this is a parabola, so ibig sabihin yung area ng spandrel natin is 1, yung n ay 2 plus 1, so that's 1/3 base times height. So ibig sabihin kung yung n natin is equal to degree 3, yung area ng spandrel natin is n plus 1, so that's 1/4 of base times height. No? So ilalabas natin yung special case. Special case, yung triangle. Alam natin na this is a line. And ang line, that is degree 1 or linear, diba? So, ang area nito is n plus 1. So, 1. If n is 1, so that's 1/2 base times height. Yun din yung area ng triangle, no? So, special case niya to. Okay. So, how about the location of the centroid? Yung location ng centroid, ito yung x-bar natin. No? Ang formula natin dyan is equal to 1 over n plus 2 of the base. So, if n is equal to 2, kasi kung ito ay parabola, ibig sabihin, yung centroid natin can be found at 1/4 of the base. And, of course, kung yung n natin is 3rd degree, no, yung curve. So, yung centroid natin can be found plus 2. So, that's 1/5 of the base. How about in the triangle? Ito, yung x-bar, no? So, yung x-bar naman for the triangle, plus 2, since this is degree 1, yung triangle, no? Plus 2, so that's 1/3 of the base. So, dun din siya nanggaling. Okay? And ito pa. Kung ito ay rectangle, no? With this base and this height, itong part na to, ito yung pinag-uusapan natin, no? So, ito yung pinag-uusapan nating spandrel. Itong kabilang side is a parabola. Kung degree 2 yung pinag-uusapan natin, ha? That is a parabola. Ngayon, para ma-compute natin yung area ng parabola, we have the area of the rectangle minus area of the spandrel. Ang area ng rectangle is base times height. Ang area ng spandrel of degree 2 is 1/3 base times height. So, dito nang galing yung area ng parabola, base times height minus 1/3 base times height, that's 2/3 base times height. So, ito yung formula ng parabola. Okay? So, konting recap lang to para dun sa mga previous topics natin. Balik tayo sa scenario. Okay. So, kung hindi ko pa na-establish itong area 4 and area 5, usually, iisipin natin na itong area na to ay area ng spandrel. No? Kung hindi natin na-visualize na ito ay dalawang area pala. No? So, kaya yung nagiging malaking problema, okay, so this is just a spandrel. So, ano yung area ng spandrel? So, tingnan natin ha. If this is x and the total length is 9, meaning this distance here is 9 minus x. So, kung yung x is equal to 5.196, no? So, yung 9 minus x is equal to 9 minus 5.196. That is equal to 3.804. So, 3.804. So, this is 3.804. And alam natin yung height na to is negative 60, di ba? So, that's 60 na lang. No? Ngayon, the previous answer natin dito, this is 103.92. No? So, since we have here 103.92, dapat itong area na to, hahabulin natin ng 103.92. So, tingnan natin na kung iti-treat natin siya as a spandrel. So, we have here 1/3. Yung base natin is 60. And yung height dito is 3.804. So, we have here the area of the spandrel is equal to 1/3 yung base na 60 times 3.804. So, we have here 76.08. No? So, 76.08 lang siya. So, ngayon, ang laki na ng problema mo kasi hindi mo siya mapasara. 103.92 minus 76.08 ay hindi 0. So, hindi mo mapasara yung ating moment equation. Wherein, ang totoong scenario kasi, this is area 4 and area 5. Hindi lang to spandrel. Area to ng triangle at saka area ng spandrel. So, dalawang area yung i-compute natin dito para mapasara natin to. No? So, ibig sabihin, itong part na to ay mali. Okay? So, pinakita ko yung mali, di ba? So, ganoon ako eh. Pinapakita ko yung mali para at least next time ma-recognize na natin yung mali. Okay. On purpose yun. We have here the area 1. So, yung area 1, kailangan natin computein. Ngayon, para ma-compute natin yung area 1, may ratio and proportion lang. No? So, if this is the triangle, pangalanan natin tong y, and this is x, and itong buong to is 9. We have here the height of 20. So, hanapin natin yung value ng y. So, by ratio and proportion, RNP, hindi RIP. That's y is to x, height is to base. So, that's 20 is to 9. So, computing for the value of y, we have y is equal to 20 over 9 times x. Okay? So, since we already computed for the value of x dito, kanina, so substitute na lang natin siya dito. So, we have here the y is 20 over 9 multiplied by 5.196. So, y is equal to 20 over 9 times 5.196. And we have here 11.547. So, we have here 11.547. Okay. So, since alam na natin yung y, no? Ito ngayon, yung y na yan, ito yan yung gagamitin natin para dun sa area 1 natin. So, this y here is this height, 11.547. So, So, since 11.547 to, ito ay 20 minus 11.547 kasi the total height is 20. So, we have 20 minus 11.547. So, we have 8.453. So, this is 8.453. Okay. So, since we already have the value of the height, no? So, makukumpita natin si area 1 at saka si area 2. Yung area 1 natin is area of a rectangle, and that is equal to 11.547 multiplied by this distance, 3.804. So, area 1 is equal to 11.547 multiplied by 3.804. 43.925. So, this is 43.925. So, yun yung area 1, no? At yung magnitude ng area 1 na to, ito yun, no? Yung height, no, na area 1, which is the height or which is the base of this triangle, equal to 43.925. Okay, so kumpitin naman natin yung area 2. Area 2 is a triangle. So we have your area 2 is equal to 1/2. Yung base ng area 2 is equal to 8.453, and the height is 3.804. So we have the area 2 is equal to 1/2 times 8.453 times 3.804. So we have here 16.078. So we have 16.078. So, etong 16.078, ito naman yung area 2, no? Itong height na to. And that is 16.078. Alam natin that the total height in this shear diagram is negative 60. So, check natin whether pag pinagsama ba natin yung area 1 at saka area 2, that would be equal to 60. So, area 1 plus area 2, we are expecting 60 here. Kasi yung height nung area 1, yun yung magiging base. Yung area 1, yun yung magiging base ng triangle natin sa area 4. And yung area 2, that will be the base of the spandrel at area 5. So, we have here 43.925 plus 16.078. And this is equal to 60.003. So, 60.003, approximately 60, no? So, that's correct. Okay, so since we already have the value of the A1 and the A2, ay pwede na natin i-compute itong area 4 and the area 5, no? So, okay, so if we are going to compute for the area 4, yung area 4 natin is a triangle, so that's 1/2. Yung base natin dito is the value of area 1, so that's 43.925. And the height is 9 minus x, which is 3.804. So, computing for the value of area 4, we have here 1/2 times 43.925 times 3.804. So we have 83.545. So this is 83.545. Now for the area 5, this is a spandrel of degree 2, so that's 1/3. The base here is the value of the area 2, so that's 16.078. And the height is 3.804 or the altitude. Now, so kung i-illustrate ko itong area 5, ang mukha ng area 5 ay ito. So, ito yung base at ito yung altitude. Diba? So, kung sa triangle, this is the base and this is the altitude. So, in computing for the area, we have the base, 1/2 of the base times altitude, and for this spiral here, that is 1/3 base times the altitude, no? So, yung height natin dito is not equal to the length of this side kasi review, no? Para dun sa right triangle, kaya ito yung height natin yung ginagamit. Kasi syempre, yung altitude is equal to this side para sa right triangle. Now, so in this case, the altitude here is 9 minus x, which is equal to 3.804. Okay? So, let's compute for the value of the area 5. The area 5 is equal to 1/3 multiplied by 16.078 times 3.804. So, we have here 20.387. So, 20.387. Okay? So, para mag-close itong ating moment diagram, dapat yung area 4 and yung area 5 pag pinagsama is approximately equal to 103.92, no? So, para mapa-close natin, so para ma-compute natin yung moment natin at point B, this is equal to the moment at 5.196 minus yung area 4 natin minus area 5. So, yung moment at B is equal to yung previous natin na moment, that's 103.92. Area 4 natin is 83.545. And yung area 5 natin is 20.387. So, yung moment at B dapat ay 0. Kung di man siya 0, approximately equal to 0. So, 103.92 minus 83.545 minus 20.387. So, we have here 0.012 approximately equal to 0. So, yung sabihin na pa-close na natin yung ating moment diagram. Since area 4 and area 5 here, kung kukunin natin yung buo, this is increasing. So, from the idea of the dYIx, since it is increasing, magbe-bend tayo ng x-axis. So, in this case, this point here is in quadrant 4, ito yung x-axis natin. So, kung i-bend natin yung x-axis, yung curvature natin ay ito. No? And this is a degree 3 curve. Kasi this is degree 2. Okay? So, this is now our moment diagram. Pasensya na sa mga lampas ng kulay. Nilagyan ko lang ng pasobra. Kasi special. Char. Okay. So, yung scenario, no, na so usually, nagkakaroon ng problema sa pag-close ng moment diagram. Kasi itong area 4 and area 5 na to ay tinitreat natin as one area lang na spandrel, no? So, kung yun yung case, hindi talaga siya mag-close, no?